Good morning, sir. My name is Vainavan Kumar Reddy. I am from Department of Civil Engineering. Today we will discuss about differentiate, translation, and rotational kinetics and kinematics. Introduction to kinematics and kinetics. Kinetics describes the motion of objects without considering the forces involved. Kinetics, on the other hand, focuses then their cause motion. Understanding both aspects is crucial analyzing movements in physics and engineering. Overview of translation. Translation refers to the linear movement of object from the point to another point. In translation, all about the object move parallel to each other. The path taken can be straight line or a curve, but the motion remains linear. Overview of rotation. Rotation involves the circular movement of an object and axis to axis. During rotation, different points of the objects move through different distances. This axis of rotation can be internal or external to the object. Kinematics of translation. The key variables translation kinematics include displacement, velocity, and acceleration. Displacement measures the change in position of an object. Velocity is the rate of change of displacement, which acceleration is the rate of change of velocity. Kinematics of rotation. Rotational kinematics involves angular displacement and velocity angular acceleration. Angular displacement measures the change in angle of rotation. Angular velocity is the change of the angular displacement, while angular acceleration is the rate of change of angular velocity. Kinetics and kinetics of translation. Translational kinetics pertains to the forces acting on an object in motion. Newton's second law states the force equals mass times acceleration. The net force determines the object acceleration is translational motion. Kinetics of rotation. Rotational kinetics deals with the torque active an object that influence rotation motional. Kinematics of translation. Translational kinetics pertains to the forces acting on the object in motion. Newton's second law states the force equals mass of acceleration. The net force determines the object acceleration in translational motion. Kinetics of rotation. Rotational kinetics, which deals the torque acting on object influence its rotational motion. The net torque determines the angular acceleration according to Newton's second law for rotation. Equations of motion of translation. The equation of motion of translation can be derived from calculus and physics principle. Common equations relate displacement, velocity, and acceleration over time. These equations are foundational for predicting linear motion outcomes. Equation of motion or rotation. Motion for rotation. The equation of motion for rotation are analogous to those for translation but involves angular quantities. The relative angular displacement, angular velocity, and angular acceleration over time. These equations help to predict rotational motion outcomes. Relation between linear and angular quantities. Linear and angular quantities are connected to the radius of rotation. For example, linear velocity can be expressed as angular times the radius. The relationships can convert between different types of motion. Examples of translation motion. Example of translation motion include a car moving down a highway. Another example is ball rolling straight down in a hill. Both instances demonstrate all points of object moving in the same direction. Examples of rotational motion. Examples of rotational motion include the spinning top or a Ferris wheel. A planet orbiting around a star also exhibits rotational motion around an axis. In these cases, different points of circular paths. Energy of rotational motion. Rotational motion is also kinetic energy expressed 1 by 2 w square, where is the motion of inertia. The distribution of mass affects the movement inertia, thus the energy. Rotational energy plays a significant role in machinery and mechanical systems. Conservation of angular momentum. Angular momentum conservation applies to rotating system and is critical understanding rotational dynamics. The total angular momentum remains constant if no external torques act on the system. This principle is vital in fields such as astrophysics and engineering design. Practical applications of rotation. Translation is linear motion, with rotation is circular motion around an axis. Differentiate equation, kinematics and kinetics for each type of motion. Understanding these differences is crucial applications in science engineering. Conclusion. The study of translation rotation fundamental to understanding mechanics. Both kinematics and kinetics provide insights into the behavior of motion objects. Mastery of these concepts open the door in innovates technology and engineering. Feel free and expand of any these slides, image, graphs, and additional details if as needed. Thank you, sir.